This is the fourth lecture of our IMAT series chemistry. We are studying periodic tables and periodic properties. Development of periodic table. Elements in the same group generally have similar chemical properties. Properties are not identical, however. Okay. Development of periodic table. This is the periodic table. Dimitri Mendel and Lotmeyer independently came to the same conclusion about how elements should be grouped. You can see here 1, 2, 3, 4, 5, 18 groups, total of 18 groups, and 10 periods 1, 2, 3, 4, 5, 6. The horizontal rows are periods and vertical columns are groups. Okay. Yeah. Development of periodic table, atomic weights. Okay. Periodic trends. In this chapter, we will explain why. Okay. We will then rationalize observed trends in size of atoms and ionization energy, electron affinity, a little bit of electronegativity as well there. Okay. Effective nucleus charges. Yeah. Sodium atom look like this. You can see here one valence electron. Okay. Total of 11 electrons and 11 protons. Okay. In a many electron atom, electrons are both attracted to the nucleus and repelled by other electrons. The nuclear charge that electron feels. The nuclear charge that electron feels depends on other factors. It is called effective nuclear charge. Okay. Electrons in lower energy levels shield outer electrons from positive charge nucleus. Yeah. Inner electrons. Yeah. This is shielding effect. Okay. Electrons in low energy levels here shield outer electron, this one, from the positive charge of the nucleus. Okay. You can see effective nuclear charge ZEF is equal to Z, atomic number is negative, seconding constant. Okay, seconding constant usually close to the number of inner electrons. Okay, n minus 1. So the effective nuclear, you can say effective nuclear charge is plus 1. Combined effect. Okay, this is 4. N minus 1 electron means these 10 electrons. This is how we can find effective nuclear charge. Which example here, which element's outer shell or valence electron is predicted to have the largest effective nuclear charge? uh, Solve it by yourself. I need an answer for this. Put your answer in the comment section. I will also pin a comment in the, okay. I will let you know the answer in the comment section. Okay, after one day. Yeah. Here's our answer. Okay, chlorine has 17 atomic number inside. Inner shell 10 electron, effective nuclear charge 7, for oxygen 6, for nitrogen 5, for calcium 2. Okay, fine for krypton. Okay, valence electron. Many chemical properties depend on the valence electrons. The outer electrons that are involved in the bonding and other most chemical changes of elements. Those are the valence electrons. Okay, rules for defining valence electrons in outermost energy levels. Okay, for one main groups elements. Okay, elements in S word or P word, electrons in field D or S are not valence electrons. For transition metals, electrons in F shell are not valence electrons. Valence electron, many chemical properties depend on the valence electrons. Okay, rules. These are previous rules. Okay, in outermost energy levels, valence electron in blue. Here you can see here, these are valence electrons. These are valence electrons. Valence electrons. Okay, blue, in blue. These take part in most of the chemical reactions and bonding. Sizes of atoms. The bonding atomic radius is defined as the half of the distance between covalently bonded nuclei. Okay, the bonding atomic radius is defined as the one half of the distance between two covalent radius. This distance. Okay, non-bonding atomic radius is electron distribution around the nucleus. Okay, distance between nuclei, bonding atomic radius 1 is 1/2 d. Sizes of atoms. Yeah, increasing radius. Radius increase this way. Effective nuclear charge is this. Okay, and down the group, radius increases and increases. Effective nuclear charge increases. Okay. Bonding atomic radius tends to decrease from left to right. What? Decrease from left to right across a row, across period due to increase in effective nuclear charge. Okay, and atomic radius from top to bottom of a column, this from top to bottom. Okay, increases due to increase the value of n. N, what is n? Atomic number. Okay, size of ions. What are size of ions? Group 1A. Well, ionic size depends upon these factors: nuclear charge, number of electrons, orbitals in which electron resides. Yeah. Okay, you don't have to remember this. Okay, values here. Okay. Cations are smaller than their parent atom. The outermost electron is removed, and the repulsion are reduced. Repulsion are reduced so that the size of cations are lesser than the parent atom. Size of anions. Anions are larger than their parent atom because electrons are added and repulsions are increased. So the size of anions are larger than their parent atom. Okay. Ion size increase as you go down a column. As you go down along the group, you will see that the ion size will increase. You can see here boron, aluminium, gallium, indium. Okay, oxygen here, sulfur down the group. This is 3A. This is 6A. Okay, due to increase value of m. Size of ion in an isoelectronic series, ions have same number of electrons. Uh, this is the important thing. Yeah, isoelectronic species. Uh, what are isoelectronic species? Okay, you have to learn this. Okay, isoelectronic species are those which have same number of electrons. Okay, charges ionic sizes decreases with an increasing nuclear charge. As the nuclear charge increases, ionic sizes decreases. Okay, you can see here like where is this one? As ionic sizes increases down the group because of increase in nuclear charge. Atom area ion size examples. Okay, yeah, list them in an order from smallest size to largest. Smallest have, first of all, you have to write those positive ions because positive ions have smaller charges. You can place them, okay, according to your knowledge of sizes, atomic sizes, and ionic sizes, okay. And I'm giving you hints here. Positive charges will come first, like you have to arrange these three as well. Which comes first, which comes second, which comes third. Then you will put neutral atoms according to their radiuses, and then you will put negative ions. Okay, okay, solve this. Yeah, here is the answer. Okay, so aluminium loses 3 electrons. Okay, so it's like you can say its size is more smaller than magnesium. Magnesium loses 2 electrons. Its size is more smaller than sodium. It loses only 1 electron. And chlorine is in, you can say, is in the 17th group. So you can say chlorine has, like, when we move in period, the atomic sizes decreases. So chlorine is on the 17th group. Yeah, you can, chlorine has lesser size than sulfur, aluminum has lesser size, magnesium has lesser size than sodium has lesser size than Cl negative. Cl negative is anion has more sizes. Okay, and then S negative 2 because it gains 2 electrons, so its size will be larger than chlorine. Yeah, start with the atoms with no number of electrons ordered in by nuclear charge. Next, neutral atom, highest nuclear charge first, last anions, highest electron first. Okay, ambiguity, anions versus neutrals. Is Cl negative really larger than Na? Don't worry, you have to solve this. Okay, but it is actually, okay. Don't need to worry about this one. Okay, you just do what you have to answer. Ionization energy, amount of energy required to remove an electron from the ground state of a gaseous atom or ion. First ionization energy is that energy required to remove first electron. Second ionization energy is that energy required to remove second electron, etc. Okay. Before studying ionization energy, let me explain some important points of atomic radius. Or okay. Yeah. Why size can't be exactly measured because of the following reasons: no sharp boundary around the atom, no sharp boundary. Number one, no sharp boundary. Next one is electronic probability distribution is affected by neighboring atoms. Okay, these are some things that you need to remember. Okay, and here's some like how you can find interionic radius. If you are interionic radius are positive, positive plus this is for cation, this is for anion, and this is interionic radius. Okay. Yeah, we were ionization energy, amount of energy required to remove electron from the ground state of a gaseous atom or an ion. Okay, ionization energy depends on stability of atom, depend inversely related to metallic character. Ionization energy is inversely related to atomic radius. When atomic radius increases, ionization energy decreases. When atomic radius increases, ionization energy decreases. Okay, and ionization energy is also inversely proportional to shielding effect. Ionization energy is directly proportional to nuclear attractions. Okay, you can see here electrons is removed from sodium atom in gaseous state. Ionization energy it requires more energy to remove each electron. When we remove one electron from an atom, it uses like some energy, but energy will be increased by removing each electron. You have removed one electron. For example, we have given 100 kilojoule. For the next electron, we have to give 200. Like for example, in the next step, you have to give 400, then 800. The ionization energy will increase as we move one electron one by one. Okay, you can see here when all the valence electrons have been removed, the ionization takes a quantum leap. Is you can see here this for magnesium, for aluminium, ionization energy is increasing. Yeah, see, ionization energy increasing. Trends in ionization energy. Going down the column, less energy to remove the first electron for atom in the same group. Atom okay, effective nuclear charge is essentially the same, but the valence electron from the far are farther from the nucleus. Okay, ionization energy increases this like this from the bottom to top. Okay, ionization energy increases like this. You can say down the group ionization energy decreases. Okay, from left to right in the period ionization energy increases. Okay, trends. Generally it's hard to remove an electron going because when we move in period we have faced difficulty in removing electron. We have to give more energy as you go from the left to right. Effective nuclear charge increases, so ionization energy increases. You can see here helium, argon, krypton, and xenon. Yeah, for these as well. Yeah, this is for group, and this is for also for group. These like decreasing, but in period it is increasing. You can see. Okay, increasing. Trends in ionization energy. On the smaller scale, there are two Japanese find here. You see here, there are some exceptions here where ionization energy like show variability. First occurs between groups 2A like and 3A. Electron removes from p orbital rather than s orbital. Electron farther from the nucleus, small amount of repulsion by s electrons. Trends in first ionization is second occurs between like group 5 and group 6. Okay, group 5 and group 6. Repulsion from other electrons in orbitals help in its removal. Yes. Okay. Electron affinity. Energy change accompanying addition of electron to gaseous atom. Okay. Uh, ionization energy. Yeah. Ionization energy also depends on you can say nature of orbital. Nature of orbital. Penetration effect. You can say ionization energy like orbitals like S. S has less penetration. P has less than D. D has less than S. Okay. Electron affinity. Energy change accompanying addition of electron to gaseous atom. Electron is added. Okay. This is exothermic. Energy is released. trends in electron affinity. Don't worry about the values, just follow the trends. They are also continuously here. In period, electron affinity increases. Okay, but you can see here beryllium and boron. Beryllium has electron affinity this, boron has this, boron must have, and in also in this case, uh, carbon has like this. So, okay, remember these like exceptions in the electron affinities. Okay, the first structure between 1a and 2a here electron added must go into p orbital, not s orbital. Okay, the trend for electron affinity is same, like it increases in period and it decreases in group. Like down the group it decreases electron affinity, and across the period, like from left to right in period, it increases. Like same trend like ionization. Okay, yeah. uh, let us see some about electron negativity. Electron negativity is ability to attract a shared pair of electrons. It helps us in bonding. I think you have to just remind this. We will study electron negativity in detail in like bonds topic. Okay, just remember ability to attract shared pair of electron is called electronegativity. If electronegativity difference is like more than 1.7, the compound is ionic. If electronegativity difference is equal to 1.7, the compound is partially ionic and partially covalent. And if electronegativity difference is less than 1.7, then compound is covalent. Properties of metal and non-metal and metallic. Metallic character decreases when we move from left to right. These are metals here. These are non-metals here. Again, they are metallites. And down the group, metallic character increases. This is less metallic. This is more, and this is the most metallic in that group. Okay. Yeah. Here are metallites. Metal versus non-metals. Metals have shiny luster, various colors, almost all silvery, salts are malleable and ductile, good conductor of heat and electricity. Most metal oxides are ionic, that are basic, tends to form cations in aqueous solution, tend to form bases, give bases when react with water. Okay, non-metals don't have luster, various colors, salts are usually brittle, some are hard, some are soft, poor conductor of heat and electricity. Most oxides are molecular substances that form acids, tend to form anions and oxyanions in aqueous solutions. Difference between metals and non-metals tend to revolve around these properties. Okay. Metal versus non-metals. Okay, metals tend to form cations, non-metals tend to form anions. The common elemental ions. Okay, let's see. Note ions in S and P word are all resolved from filling or emptying a substance. These are noble gases. Okay. What about transition metal? What is going on there? Where are transition metal? Some are there. Okay. Transition metal ions. Okay. These are like these groups all are transition metals. Okay. And many have plus two charge. Okay, many of the transition metals have plus two charges. They actually lose all their ns electrons first, and then electrons from these substitution. Okay, manganese loses two electrons, Mn2 from 4s, and converted into this. Copper loses one electron from s. Okay, this is 4s1 actually, 4s1 and 3d10. Okay, there is mistake. Okay, 4s1 and 3d10. Metals tend to be lustrous, malleable, ductile, and good conductors of heat and electricity. Metals formed between metal and metal tend to be, yeah, this is what finds the, like you can say alkali metals and halogens. You can say form ionic compounds because of their electronegativity differences. Metal oxides tend to be basics. Non-metals, dull, brittle, poor conductors for heat and electricity, tend to gain electrons, acquire noble gas configuration after gaining electrons. Substances containing non-metals are molecular compounds. Most non-metal oxides are acidic. Metalloids have some characteristics of metals and some of non-metals. For instance, silicon looks shiny but is brittle and fairly poor conductor. Group trends. Okay, alkali metals, soft, metallic solids, comes from Arabic words ashes. Alkali metals found only as compounds in nature, have low densities and melting points, also have low ionization energies. You can see the table here. Okay. their reactions with water for famously exotherm. Okay, exotherm. Alkali metals accept lithium with oxygen to form peroxide. Potassium, rubidium, and cesium also form superoxide. K plus O2 KO2 produce bright colors when placed in flame. Alkaline earth metals have higher densities and melting point than alkali metals, have low ionization energies but not as low as alkali metals. Okay, alkaline earth metal, beryllium does not react with water, magnesium reacts only with steam, but others react readily with water. Reactivity tends to increase metal. Okay, down the group, the reactivity increase as we move down the group. For alkaline earth metals, group 6A, this is oxygen family. Oxygen, sulfur, selenium are non-metals. Tellurium is metalloid. The radioactivity polonium is a metal. Okay. Oxygen, 2 electrons, O2, ozone, 3 anions, oxide, peroxide, superoxide tends to take electron from other elements. Okay, this is all structure of O3. Sulfur from S8 molecule, weaker oxidizing agent than oxygen. Most stable allotrope is S8 inner ring molecule. This is most stable one. Okay. Halogens, prototypical metals, comes from the Greek halos and geneno salt formers. Group 7A halogens large negative electron affinities, therefore tend to oxidize other elements easily, directly with metals to form metal halides. Chlorine added to water supplies to serve as disinfectant. Okay, these are properties. Chlorine properties disinfectant, react with metals for metal halides, tend to oxidize other elements easily because they are like oxidizing agents because they reduce easily. Noble gases, astronomical ionization energies, positive electron affinities, therefore relatively unreactive monatomic gases. Okay, noble gases is known from three compounds: the F2, the F4. I tried this is the F4. The Electron forms only one stable compound, KrF2. The unstable HARF was synthesized in this is German words. Here, so this is for the today topic. I hope you enjoy this. Okay.